For this video, I'm going to walk you through how to create a powerful Node.json database, all equipped with a query API, explore the file system API, and write various algorithms to handle data read, search, and write. Support this channel by liking or commenting on this video. Subscribe so you don't miss out on anything. Now, let's dive in.
So I actually going to start the project by using a template that I create for Node and TypeScript. You can actually go, I'm gonna leave the link below. So I'm gonna copy this and bring back to my terminal here. I'm gonna do a git clone, paste this link, and then I'm gonna call it JSON DB. And like that, we're gonna go to, and we're gonna open this in WebStorm. Check my few videos how to set up this server. You can see we can have a couple things here. We don't need this. We can keep this, but we don't need most of this. And I'm gonna do npm install. I'm gonna bring out my terminal here to be right on the top. I'm gonna npm install so we can have everything good. And then I'm gonna configure my ESLint to actually use this project and save changes, format things on when I save files right there. So let's explore this idea first. Let's say you have an interface. Let's use a to-do, standard to-do here, where you have an ID, which can be a string, a name, which can be also a string, status. So status can be pending, let's say completed. It can be archived, and we can also have user. You can have user, and then user has a name, something like that. So the way I can picture this, let's say you have a syntax where I can just create my DB, something like JSON DB. And then I can say this is a to-do JSON DB, and I can just give it a name. This is pretty much the data how I picture us to creating database. Just this simple, nothing complex, nothing crazy, and we can just do it like this. So let's try to support this. I'm gonna create a directory here called DB, and in there I'm gonna create our JSON DB. So I'm probably copy this file. So I'm gonna do JSON DB. It's gonna be TS. So I'm gonna do ask me this again, and we can see here it takes a type, so generic. So this is probably a generic thing, and it takes a name of our database, or maybe this is the name of the JSON file that we want to create. So here. First, I'm gonna import the path that I'm definitely gonna use, because we're gonna have to do this. So I'm gonna do fs for module. I'm gonna export a class because this is started with a new, so it has to be a class. Could be a constructor function as well, and JSON DB. And first, because it takes a generic here, we're gonna have to say T. Here it can be anything. We're just gonna say T. But because this is a JSON and I want to extend an object, it can be a lot of things. But in JSON, it narrows down to arrays and object literals. So we're not gonna have maps or sets or other type of objects inside of JSON. We know, so this is a very thing to know from the get-go. Like JSON has limited types, so we know we're not gonna have undefined. We're only gonna have null. So this also dictates how we're gonna program this entire thing, because we can only focus on those things, especially when it comes to doing certain tasks. checks. So here I'm gonna create a private read-only file path. Read-only does not mean we can write it through it, but we can only write to it on a constructor. So it's very important here. So we know we take a private file name. I'm gonna make a string here. So this syntax automatically creates the property in the class. So it's a nice thing. So here we're gonna update the file path. So that's the only place which is not read-only, which is can write. So here we're gonna create use our path. We're gonna join the current directory. You could place in a, like, especially if we when I did it on a NPM package, I made it so it creates this thing on the root project of your on your project root directory instead of right here. But for this, I just want to be able to see this. I'm gonna put it here. So we're gonna just take we're just gonna take the file name as is, and then we're gonna just append JSON to the end like that. Nice. So now we're gonna do something which can be a little bit bad, but don't care much. I just want to guarantee that by the time you get the instance, everything is ready. So it's kind of blocking. So we're gonna check if the file doesn't exist. So fs exist synchronous. That's the bad thing here. So we're gonna do file path. It's only bad if you. This is pretty quick, so I'm not too fussed about it. So we're gonna write file as well synchronous. We're gonna do file path, and we're just gonna do an array, and we're gonna say UTF-8, and just like that, we have our stuff. So let's try it out. So I'm gonna now that we have this, I can just do import, and it just good. So now if I run this, so you just have a couple commands on these things. We can have local, so we can just do npm run local, and we're gonna see that it created a to-do JSON here on the same place, and it puts an array in there which is empty. Pretty cool. So we got the first part. So what's next on the experience? What does the insert an item would look like? Let's say we are inside of asynchronous function. Maybe I can just do this. I can create the ify function. We're gonna do async right here. So it's a set function that calls itself. So let's say I want to create my to-do, and I want to await, and on a DB, and want to insert an item. And I'm gonna do ID, and here I'm gonna use the package for environment. I'm gonna create a random ID. I'm gonna name a famous go to gym. By the way, did you go to gym today? Go to gym. Let me go to the gym. And status is gonna be pending as always. And from user, I'm just gonna say it's from John Doe, our famous John Doe here. So yes, complaining there's no such thing, but the insert should be just as easy. We just want to insert something, we just pass it the thing that we want to. And one thing I want to is, because we pass this to do here, it should check whether the object is what it is here. So we're gonna, because it's TypeScript, we can use this TypeScript to validate our stuff instead of having validators for our database, and we can just rely on the types to make sure things are right. So let's support this thing. So it's an insert. So we go back here. We're gonna add an insert. So what do we learn from the insert? We know that the item here is T, because that's what to do is. And what we're gonna return, an item. So I'm gonna do item equals actually we know we're gonna return a t back as well, and we also gonna know that this is an asynchronous function. So let's hold on for the logic here. So we know it's an asynchronous actually takes an item t and returns the item t, but in between here it saves that to the database. Before we do the thing here, we need a way to actually save and read from our JSON. So I'm gonna create a private asynchronous method called read, and it returns a promise, which is an array of t. It's all the item, just like that. And here we're gonna return, we're gonna JSON parse and here is where the secret is. So I'm gonna use a promise version of the file system. So here I'm gonna do couple things. I'm gonna import the read file and the write file from promise here. So here we're gonna first await on the read file, and we know we're gonna use this file path, and I'm gonna tell it's UTF-8, and that's it. We're just reading the file here, and then here we're gonna do the write. So I'm gonna call it save. And save takes a data, and I want to picture this. So there will be times where we want to save the entire list. We want to resave. Maybe we fetch the entire data, and then we do a couple things, changes in place, and then we save the entire list again. Or we just want to save a particular item in the current list. So there's two scenarios. So that means we're gonna receive item T or an array of t to be saved. And here we're gonna try catch here this guy. I'm not gonna use a lot of try catches because I definitely wanna, maybe we can skip the try catch here. But I'm only gonna use try catch whenever I want to throw an error which is meaningful. But most of the time I'm just gonna throw the error, and then you can catch it when you're using the thing. Like for example, rather wrap this entire try catch instead of so that's gonna be up to you. So inside here we're gonna do the content. Content should be data, and what we're gonna do, we're gonna return write file and this file path, and we're gonna JSON stringify this guy. Content. We're just gonna JSON stringify the content here, but in the middle, and here we're gonna say we're just gonna error log here, and if I want to throw a nice error, I could just say throw new error, failed to save data to file, something like that. It's a nicer error than whatever would come back out of here, but we're also gonna have this inside, so it's redundant. It's a little weird to catch and throw unless you're doing something meaningful. But here in the middle, that's where we're gonna check, did we actually get an array of item, or do we get the thing? So if we didn't get an array, what we're gonna do, if it was not an array, so if it's an array, we're just gonna save it as it is. That means we're just gonna update the entire list. Or if it's just an array, if it's just an item, we're gonna say, we're gonna await on the read. We're just gonna read the entire thing, and then we're gonna content push data. And now content is the list. We're gonna push it to it, and then it comes back, and then it adds one. So this is how we add, and this is how we save the data and the list as it is. So we just got that. Next, we can just focus on our insert. So we know that insert, we first need to await this, save, and we're gonna save the data. We're gonna save as it is. We're just not gonna care. Actually, the data is much item. No, item is much better than data. And then we're gonna return the data itself because we save it as it is, and we're gonna return the item cells because we save it as it is. So one thing I want to also keep track is the size. So instead of reading the thing and collect the file size, I'm just gonna manually update this thing. So I'm gonna make it a getter and return size, and then when we insert, we say that this size plus equal 1. So yeah, we know whenever we insert, we update this, and that's it. So here's complaining. We don't have to say anything there because it's implicit. We can just say promise t, the type. So we don't have to, unless we configure this, that we have to explicit return definitions, but we're not gonna go there. So with that, we come back here, we see this, and then we're gonna log the to do there, and then we're gonna run the server again. PM run local, and like that, we can see that we have our item logged. It worked perfectly, and we can check our JSON. I can actually reformat this, and we can see that yeah, he added it to the thing. So now I'm just not gonna do insert again. What next can we do? The next one should be how to read one. So we insert one, now we have to read one. So how do we want to read this? So maybe a to do, I want to await to say db read, no, get one. I'm gonna get some inspiration from MongoDB here. So get one. So get one what? We just get everything by ID. We just say this would be an ID that we pass it here. How do we get something? I'm picturing something like this. That's where the query API comes in handy. So I want us to get one where, so something like SQL. I don't know if you're familiar. So I want to get something like status equals, pending. We're gonna get something that where status equals pending. But then when do we know we are? I also can continue this. Like I can just go where user.name equals John Doe. So I want to get one where status equals pending and username is equals John Doe. Look at the syntax, user.name. So it means if I have user, let's say list dot first item dot value. So that'll be a valid syntax as well. So we can say list is an array, we get the index 0. So this is pretty much dot notation. So that we want to support, it would be nice. So we can get values that deep or compare deep values to something. So the problem here is when do we know is done? So I'm picturing something like we can just say run. So we run this query. So we create this query. Now we're gonna run this query. So this can be many things. This could be equals, could be, I don't know, what are not equal. It could be greater than or less than, greater or equal than, less than. We can also do matches. And we can pass a regex here when we need it. We can also say where value in something or a value is between two values or something like this. So we can picture, so we can do a lot of things. So these allow us to granularly find the item in the list. We say where this is equals to this, where is that. So we can stack this to make sure it create occur the same way we do in SQL, where item is equal. But in SQL also what we do is we define which properties or which field we want to get from it. So I'm picturing here we can say get name and let me get the username here just to see the return an object which only contains name and the username, perhaps the status. So we're gonna do comma separated things, but we're also gonna use dot notation to get deep values. For example, if name had something else like avatar or anything, we want to get those keys. We just want to get the keys that we want. So we want to get the name key inside that user object, for example. So this would be a nice syntax, and then we can just log this to do here to see how we do that. So this is a lot of problem here. So first, we want the ability to compose an item based on the key arrays that we get, or the key common values, the comma separated values that we get. The other problem here is how we fetch deep values. So that's the problem. We need to create a script to be able to get deep values from something like this. So we should be able to get something as shallow as this and as deep as they goes from this. And the other thing is we need to create a way to collect pairs. So I'm gonna call these matchers, and then we have the runner. So we have the matchers and the runner. So this is gonna do matches and this is gonna run. So a lot of problems here. So one thing, whenever you find any situations like this, yeah, you have a problem. This is our problem that we want to solve. But then inside this problem, we have many sub problems. We have this, we have the keys, and we have the runner. So in here, I just identify 4 high level sub problems inside this problem that we want to solve. So you always want to approach your problem like this. So we know the API, how it looks like, now let's support it. So how do we support this? So which sub problems we want to tackle first? And I'll say, let's first add a way for us to collect this deep value. All right. So I'm going to create a utilities directory where we're going to add various things here. And so for that, I'm going to create a file, say get keychain, get keychain value. We're going to create a utility here to get a keychain value. All right, so I'm going to export a function. So what does the gis keychain say? So we know we're going to have to wait for the keychain, which is going to be a string. This is whatever it's passed here. So username here, user.name. So that will be there. And we're also going to get the data. So what data is going to be? I'm going to say it's an object literal. I just want to say object for JavaScript. So I actually am going to create the types.ts. This is, I'm going to export object literal. But it's going to be a type. The object literal is simply a record string and an unknown value. We don't know this. We don't know what value we're going to get. So get back here. We're going to say import the object literal. I believe it's 2 steps back. And what we're gonna do is, well, we don't know what we're gonna return. So I'm gonna say unknown. But we don't know what we're gonna return from this get object. It could be nothing. It could be something. So the first thing here, we're gonna break the parts. So we know the keychain has dot notation. So we're gonna do a string. Maybe the string is overkill. Keychain. Hey, the keychain doesn't have a G. Keychain, we're gonna split on a dot. So now we have the parts. We have the individual parts here. So first we're gonna start with a key. By the way, I'm gonna make this a call recursion. Check my video on recursion on what that is. And we're first gonna get a first key, and the first key is the parts shift. So what shift does is return the first item, remove the first item in the parts, and returns it. So parts will have the parts is parts minus the first item at this point. And now we're gonna get the value. So the value of this is what? Is the data. We're gonna get this data from the key. So so here comes the problem. So here is complaining undefined cannot be, because shift can be, array can be empty, and shift will return undefined. So I'm gonna say a string, and that fixed that. And I'm also gonna treat this an object literal. It's not always object literal. It could also be an array. We know in JSON you could either have object literal or JSON, and they both works with dot notation. But for sake of simplicity over types and not having to specify when is data, when is array, and when is object literal, we know that the dot works with either. So we're just gonna treat everything as an object literal. So we're gonna return the value. So whatever the value is. But this only gets the first level. So we get that object, so to say get status, this would work. So we just get status, and it will return status, and then status will use it against the value, and then the value will return what actually status, which is in the case on the item or they have in the list, would be pending. But how do we keep going? So we know if there is more parts, if the more parts, probably the user wants a deeper value. So in this case, we gonna check if value and type of value equals object. So what did I do here? So if value means I didn't get undefined or null, and the type is object. So null is also considered an object. So this is a good check to do. So if it's JSON, the only object we're gonna have again is array or object literal. So if it's value and it is an object, we're gonna continue deeply. So if it's not that, we know we cannot get a dot name of a number. So that would be an error. So a new error. We're gonna say cannot get, putting quotes here. We're gonna join the parts, join. We're gonna get join of. We're gonna say value directly. We're gonna be funny print whenever it comes to, because if it's not object, it's gonna always print nicely. So we cannot get value from it. So that's an object. But if it is an object, and we have a value, and there's more parts to go through, we're gonna continue. So this is a recursion. We're gonna call this thing again. Only this case, we're gonna join the parts for the new keys. So remember, the parts here does not include the first one. It only includes what's after and on forward. And the object in this case is the actual value. So we got the value. So now we're gonna go drill down through that value part. So we're gonna continue and continue and continue until eventually there's no parts, that this object infers no parts, and it just collect the value and just gonna return the value. And it's just that simple. Okay. So we solved this problem. So now let's solve an different problem. Let's solve the matchers. The where equals. How do I approach this? I definitely see this as a standalone. So we're gonna create a new util. I'm gonna call where.ts. So let's picture this. So how do we chain things in JavaScript? So I'm gonna export const. It's actually very simple. And the where here is just so let's picture this. So if I wanna call, so if I come back here, I know that the get one returns an object. It returns an object which looks like this. It looks like where. It returns an object where I have either a where or a run method, right? And then from the where method, whenever I call that function, I get a different object which has a bunch of matchers, right? And then eventually these matchers return the object that get1 returned. So object get1 returns an object which has where and run, and I can call where, and then where returns a new object which return equals, which collects the value and then returns the object that get1 returns. So that's a loop. So that's how we gonna be able to perform these things. Let's first picture where the where come. So that means the get1 should be able to provide a collector. I'm gonna call it a collector. Actually, let's create a collector. What does a collector look like? Types here. So let's export a type collector. A collector should be a function for sure. And I don't think he really needs to return anything. But a collector of what? I'm gonna say T again. Let's use T. What are you collecting? And I'm gonna need to collect the key, which is the keychain. Actually, this is a keychain. Let's create a type for keychain. Export type keychain. Keychain should be a T. Should return a T as well. Keychain should be a key of T or a string. Why a key of T? So we can check here. A keychain is a key of T, means a key of the item, and status is a key of item, but username is not a key of the item. User is, but name is not. So this we're gonna consider a string. So key of, and it could be a key of T or string. So here we're gonna see a key, and we're gonna pass the T again, propagate the T. What else? We also need a comparator. Comparator. A comparator, I'm gonna create a comparator as well. So just so you can have an idea what a comparator is. And I'm gonna export this. It's gonna be enum. What is a comparator here? If you remember here, what actually compares these guys? Equals, not equal. So we're gonna say equals, not equal. Remember, the where should be able to tell us which key. So where needs to tell us a few things. Which key or keychain, what comparator we're using, and what the value is that we're comparing it against. So these are the three things that this matcher actually provides. Which keychain or key, what comparison we are doing, and what value we are comparing it to. So we're gonna comparator is not equal. Like I said, we're gonna do a between. These are very easy to implement. Greater than, greater or equal, less than, less or equal. And we're also gonna do what else? Matches. Matches is the new one for the regex. Greater, remove unused read only, greater equal. Sit down. So we're gonna collect the comparator and the value. The value can be anything, so it's unknown. We don't know. I'm not gonna use any. It can actually be anything, but it's unknown. And we're gonna return void. So here we're gonna say the collector should be a collector. And we know a collector takes T. So that means this needs to take a T as well. And here, what else do we oh, the runner that we want to run at the end. It could be a simple promise, a simple function that returns a promise. We don't care. We're not gonna pass anything to it. At least I don't think we will. But what are we returning it? A promise of what? I'm gonna say R, and we're gonna return an R here. It will make sense. So a where returns what? Returns a function. Remember, where is a function, so it returns a function. What does it get? The key, which is the keychain of T. And what does it return? A return an object. So it returns an object which contains all these comparators. So we're gonna return equals, which are also function, and what they look like, they correct a value, and they return what else? They return the same thing, the same object. So how do we loop this? We return another where, which is a call for this where, and we're gonna say it's the same type. We're gonna further drill here, and is passing the same collector and the same runner. And we also have the run, which is the runner. There you go. So that's how we loop. So the call where is a function. It takes the key and then returns a new object which contains all the comparators, and we're gonna introduce that. And then this comparator, for example, the equals returns gets a value which is unknown. We don't know what we compare it to, so we unknown. And here we're gonna collect. So we're gonna call the collector to say, hey, it's only here that we got the key, we got the comparator. The comparator here in this case is equal, and we have the value. So now we call the collector, say, hey, we have the key which collected by the where. We know the comparators because we inside one, and we return the value because now we collected it. So we're gonna keep doing this. I think this is a little repetitive. So not equal. So it's gonna be the same thing, but it's gonna say not equal. Not equal to. Not equal. So the same thing. We're gonna see here is kind of repeating. I'm gonna create a return here. I'm gonna call it loop, the loop object. Just gonna return loop. Yeah, so we're gonna continue this. We're gonna do for in. What in takes? In takes an array of unknowns. And in. And we'll just do between. What between takes? Between takes an array. It has to be number. Number. So tuple. So between. And we're gonna say here is between. What else do we have? We had matches. I'm so excited for matches. What the value of matches? The value can be, I want it to be a string, which I can definitely turn into a regex, or it to be a regex. Regex B, I believe that's how it is. And we're gonna say matches. Speed it up so you don't see me typing. Greater. Then greater than should also be a number. less. So equal. Beautiful. I think that's all. So we can see now the where is pretty much all set. Good. But let's go back to our to-do here. So how do we actually call this? So we have a private async. No, not that private. It's here. We have an async get one. How do we collect this? We cannot just call. Remember that these are gonna return an object, so we're gonna have to return an object where we have where and we have run, because this is how we have this. So we call get one, we return where, and we return a run, and the where has this thing. So the where has to be a call for our where, and we have to pass the collector. But I think I'm rather let's create a function that will just do that, because we're gonna have to collect for everything, every action that we do. So we're gonna create collect.ts. I'm gonna export const collect. So what the collect, I wanna know when I'm done. So here inside this, I want to be able to loop and loop and loop, and looping inside the get one cannot be easy, so it's rather have the function which I can call again. I mean, the loop will happen inside of where, but what are we collecting? So I'm gonna just start with its function here. Save void for now. So we're gonna collect matchers. I'm gonna call them matchers, which is what I call here. So this is a matcher. Call matchers. I'm actually gonna create a type for matchers. So the same thing we have here, like these are the matchers. We have the key, the comparator, the view. So I'm gonna export, because here is a function. A collector collects the value, the keys, the values for the matchers. So that will be an interface. The matcher takes a key. Same thing like this. So it's pretty much what we have here, but now inside the object. Make this like this, and the matcher now also takes a t. That's pretty much what it is. A matcher is just an object. So we're gonna collect this object. So we're gonna say array of matchers. So we're gonna say t. So that means collect should also takes a t. Oh, wrong place. And we're gonna pass it. So we're gonna create a matcher. And it's just gonna start an empty array. Oops. Matchers. We're gonna call it matchers. So then we're gonna return the object that was just returning inside here. Just gonna return it here in the collect. So here we're gonna call the where. Same folder. I don't know why my thing is doing this. So we know the where takes two things. It takes a collector, which is gonna be a function, and we're gonna and we know it's gonna be a key comparator. We're gonna take a value. So we're gonna push matchers, push an array, key, comparator, value. It's complaining about type. So I'm gonna say T, and I think it also takes an R. So let's make this thing also takes an R. So this is return value. So why T? The T is the type of the object we have. The R is the return value of that type. Like I said, R can be the T itself, but also R can be a subset where we just use the keys to represent those. So that's why I'm calling it R. R is the return type of T. It can also be T, but you know, I don't know if you get it right at this point. So TT. So also it takes a runner for the where. So let's create a runner, and we check, and the way I define is the runner is a function that returns a promise. So we're gonna create const. We're gonna call it run. We're gonna make it a sync, and this is pretty much a function that calls done. And I'm gonna call it matchers. So here we know that matchers result. I'm gonna call it result instead. So we know this is gonna be an array, and it should return the R. So now we can just return this run. Oh, it just matches this. So perfect. So when we call this, let's by the done. So now inside here, all I have to do is return collect, and for now I'm just gonna matchers. I'm gonna log matchers. But collect takes something, so we're gonna pass T, and whatever you're returning this, we're returning a promise. The get one returns a promise. Which can be the item itself or partial T. What matchers is, we're gonna make this asynchronous. Why is this complaining? Matches a precise type of any, or maybe because this is not correct. Should not complain about that. So we have, what did I say here? Done should be a function. Oops, I think I messed up here. Done should be an array. This, yeah. So let's go back here. See that. What is the complaint? Why is it not happy? Oh. Could also be null. If in case we don't find item. I'm gonna return, because we never return anything here, so we're gonna say return, and we're gonna make it asynchronous. There you go. Good. We're just gonna log this for now. So we are collecting, we know the matchers here. When we collect the matchers, what we have to do is actually go through our list, find the item, and then use the matchers to actually find the item. So let's see if this works. We have here, see, everything is good, but let's, we're not handling this, so we can just start by saying keys is a keychain array. The array. We're just gonna log the keys as well. beautiful. So now if I run this, see if I have an error here. Oh, some reason my WebStorm is not doing a very good job auto importing stuff. So now if I run this, npm run local, we can see, there you go, we are collecting our matchers. So we have the keys and we have the matcher. We see which status comparator 0. 0 means because it's the in a enum, pending, and value John Doe. We want to think. So we have the comparators we need to go through, which know it's an array. We know the keys. We need to. Let's first handle the comparison. So how do we collect this comparison now and convert them into true or false? For that, I'm gonna create an array. Let's create a utility where let me see what I call it. I'm gonna call it match data key value, not TS. So this is what we're gonna use to compare the values. So what does it take? We first need the data, which is T. It's the item. So that means this thing needs to be T. And we need a comparator. Oh, not a comparator, the matcher, which I'm gonna destruct. I'm gonna say matcher of T. This thing's not doing a good job here. And we know it's gonna be comparator key and value. I think this should no, I don't think this should be well, I just realized I have a problem. No, I don't have a problem. So what's the value? I'm gonna call it val. Then I'm gonna get get keychain, and I'm gonna pass it the key. Key can be a string or thing. And you're gonna pass the key, and then I'm gonna pass the data. This should give me the value. Remember, we wanna have the value to compare to. It's complaining this, oh, because that's waiting for a string. Maybe I can just do keychain here. I don't want to complicate this, so let's just do a string and this as object literal. Just not complicate things here. So we have the value now. What now? So we're gonna do a switch, and we're gonna pass the comparator, and at the end we're gonna have the default saying return false. So this clearly returns a boolean, so we're gonna have a case for all of them. I'm gonna do equals. So it's just as simple as saying now we have the value here, and now we have the value from the keychain. We can just say is val equals value. That's just it. Look here that I do strict comparison, not equal, and that's it. Not equal. In between, we know that the value should be number. Everything should be number. So I'm gonna say number just in case it's not number, which is unlikely with TypeScript because it's gonna scream. But you know, some people just overwrite stuff more than. Oh, this is gonna be weird. So, and then we're gonna do value, but we're gonna treat it as array of number. gonna wrap this guy. It's a wrap inside a wrap. I'm gonna get the first item. That's minimum. So it's greater or than the minimum and less than the max. So it's actually in between. This is complaining here. Let's add a comparator here. So then we're gonna do the in, and we're gonna return same weirdness. And in this case, I'm gonna return val unknown includes val. Yeah, and then greater than, greater or equal, greater than, less or equal, less than, and I have matches. Greater than, greater or equal, we're gonna say number val greater or equal. I'm also gonna make it a number. This is unlikely to happen because we have types that we declare. No, greater than, less or equal, less than, and matches. We're gonna return a type of value equals string we're gonna return new regexp, where we pass the string, we pass the value, and then we test. Make this a string. Otherwise, we're just gonna save value as regexp. Same test. Yeah, regexp. So there you go. It's match data key value. It's just as simple as that. So now that we have the matches, we have a way, we have the matches, we have a way to do that. Let's collect the item. So we're gonna say const item, what item is. So I'm gonna first read this read, and we're gonna do a find. Remember, it returns an array, and we're gonna get the item. And here we're gonna do a return, and when we have a matchers, we're gonna say make sure that every matcher matches matcher. I'm gonna call the match data key value. I'm gonna pass the item and matcher. I believe that's the order. See, pass the data and the matcher. Okay, yeah. And then here we're gonna say if item return item. Otherwise, it's gonna return null. We're gonna have to come back with this because we're still not handling keys. But let's just make sure this works. So I feel like there's some errors here. This thing never gets these things right. Annoying. So okay, so now let's run this guy. What do we get? We got null. What did I do wrong? Get one. Get Mac is undefined. Do I have anything there? Status is pending. User.name is Kajando. Ooh, I think I know what it is. I forgot the return. There you go. Forgot the return this guy. Maybe can just do this instead. Nothing like the console log doesn't fix. That's how you spot the front-end engineer. You only use this console log. So let me just run local again, and voila, we got the item. Beautiful. Now we just want to make sure that we got only the keys that we need. For example, I don't want the ID. I want the status. I want to just get the name. So let's handle that. So I'm gonna create a utility that says create item from keys.ts. We're gonna export this. Const create item from keys. What is create item from keys? It should be very similar to get keychain value, but it's actually creating the item while it's doing this. So in this case, I know that I'm gonna return an object literal. So I'm gonna call a partial item, which is gonna be this. I'm gonna return it. I'm gonna do a bunch of things. So what does this thing needs to take? So we're gonna do a keys, which is gonna be keychain array. No, I'm just gonna not bother with keychains because too much types dependency. I don't think this should be worried about. So the same thing we're gonna do is object literal. So we receive an object literal. So I'm gonna do pretty much the same thing here. Keychain data, but we're gonna create an item instead of collecting. So we know we're gonna get an array of strings. Why are we gonna get an array of string? Well, I'm gonna pass this. So we're gonna comma separate when we call it here. Yeah, so we have to check for each one. So this gets a key. So this is what we have to pass into that create item from key. So that's where it receives it. And the data is actually the item. So here, when I found the item, I'm gonna pass the item and the keys. And that's where it's gonna drill down and create this object literal, and it's gonna create it inside this object that was there. So pretty much copying it, the keys that is relevant. So the first thing I'm gonna do is loop over this thing. I'm gonna call it keychain. Keychain. And here I'm gonna create a target. Let target. So target equals the partial item. So every time I start this create item from keys, I'm going to start from the target, but the target keeps moving as I drill down. And where the source is, so we have to match the drilling with the source. So we have to drill the drilling from the target with the sources. So if I jump into the user object, I create a user object here, but then I have to drill down into the data to say that's the user object. But then we have to keep doing this on and on. So now keychain we're first gonna split it again. Split it for the dots. And then for each part, we're gonna have the key, the index where it happened, and we have all the parts. All is gonna come relevant. Whew. So the first thing we're gonna do is get the value, same way we did before, and we're gonna get it from the source. Key, we're gonna treat it as an object literal, but it can be anything. Here we're gonna say if value is undefined. Why are we checking for undefined specifically? Undefined inside a JSON does not exist. You cannot have a JSON undefined inside a JSON. And whenever you parse it into an object JavaScript object, the everything becomes null. You can only have nulls. So if we get undefined, it's because that key doesn't actually exist in the object. Of course, this is, I mean, you can argue that, say, oh, maybe the key matches the prototype, something in the prototype. Yeah, which sure, it will have matched it. Maybe you can add something for that, but I don't care for that in a moment. So if that's the case, we're gonna throw an error saying key does not exist. Does not exist in source. So now we want to know when we are at the end of this loop. Are we on the last key? So we want to make sure this is the last key. Is last key. And the way we check is last key is if we know the index equals to parts length -1. And then we're gonna get we're gonna create the value in there. So we're gonna say target key equals either the target key already there. So it could be that, for example, let's pretend that user has avatar, which is also a string. Nah, maybe I not type this. But let's say the user also has another thing. So if I go with let's say in here, I'll say user.name, and then I can say user.avatar to specify a different key that I want from that user. So if I went once, I create on the first time that I create, the first time that I look for the name, I'll create user with object. And the second time, I don't need to create the user object. I just need to get it and then set that value in there. So here, that's why I'm saying here, the key should be either the one that already created previously, or this is where the complex is. We're gonna say if it's last key, we're gonna do another thing here, another one here. If it's last key or not. If it's last key, we're just gonna return the value. Actually, if it's not the last key, we're gonna have to compare. We're gonna say array is array value. Then we're gonna create a new one. We're gonna create a new array. Otherwise, should be object literal. That's pretty much what it is. So what I'm saying is, if we reach the end, just the value for this key should be the value itself that we collected. Or if it's not, maybe because the user doesn't exist, the user object exists. If I check the source, and in the source the object is an array, then I create an empty array. If it's not an array, then I create an object. This is taking into consideration again that in JSON you can only have array or JSON object literal. So then the target, we need to update what target is now. The target is pretty much this. So we're drilling down now. So we as object literal. And what's the source? Now the source is actually value, whatever we got in the value. Pretty much what it is. Okay, so now we got that. So what we're gonna do with it? We're gonna come back here. We're gonna improve this boy here, and we're gonna say if. This is how we know that maybe if they didn't provide keys, we're gonna return create item from keys, and we're gonna pass keys as string. I know you're gonna freak out, and we're gonna pass item as object literal, and yeah, let me prove this because I know this guy did a good job finding my utility. Let's see, do we get any freaking outs of this? So he's saying something not right, so we're gonna say, hey, come down. This is actually return a partial t. Yes, beautiful. Now we know if we provide item keys, we can create an item from there, and now from the right we just return as is. So this is what we had before. So if I run this thing again, something not right. Oops, what did I do here? Oh, there you go. Nice catch. Invalid JSON. I just had a comment here. Jeez, I cleaned everything. So I'm gonna run local, and we can see now the object that we got was just what we requested. So here we can go back. I'm gonna show you this. I'm gonna remove status now. Actually, we just care. Let's say I just care about ID. And if I run this, when it queries it and returns, it just want to return the ID. Maybe I just want the username. And there you go. And I'll run this. I got the object that I need. So perfect. This is nice. So as you can see, I pretty much solved everything already, at least most of it. So what about get all? Maybe we can just copy this guy. So now as soon as we're gonna finish up this video, to do's, I'm gonna pre-chart the same thing, get all. Look how beautiful. So I'm gonna say get everything matches this, that match this thing. Same syntax, pretty much everything. We're gonna use the same syntax for everything. Maybe update one, delete one where status equals pending and the user is equal to, or delete one where ID is equal to that, or get all highlighted. So all we have to do is copy this boy. We're gonna do get all. So we just collect in the same way, but we're gonna do a filter instead. And this is gonna create the items. And the promise, the return hierarchy is gonna be array of t, partial array of t, or no. And so the items, we're gonna filter every matches. That's gonna be the same. So here I don't care. I'm gonna do items. Actually should never be null. You always return an array. It can be the empty or not. So even keys length. So in this case, I'm gonna do items map, and for every item, I'm gonna return this boy, which is pretty much the same thing. So let's see what get all does. I'm gonna return get local, and you see it returns the same thing, but you see it did the thing, and then actually let's add new items. So I'm gonna insert something again. I'm called Jane Doe. what Jane Doe does. Completed. Go to fitness class. We're gonna insert something else for John Doe. Buy groceries. Archived. And we're gonna enter another one. John Doe, completed. No. Create YouTube video. And here I'm gonna query everything that's from John Doe. And I'm gonna run this query once so we can create these items. We can see it returns everything from John Doe. So I'm just gonna comment this out because every time I run this script, it's gonna create a new database and new items. So here, so we get everything. So I want to get everything that's pending. Do we have any items that's pending? So we only have John Doe here with a pending item there. So cool. So what about updating an item? So it should be the same thing. So I'm just comment all here. Update 1. So I'm gonna update 1. And update does not take this. It takes actually the data. So we want to update. We want to update everything to complete it. Completed. We're gonna update every John Doe items to complete it, that which are pending into completed. Good. So how's the update one looks like? Well, it's down here from here. So I'm just gonna copy get one. And update 1. So update 1 takes a partial t, and we're gonna call it data. It's gonna be partial t, a partial t. We don't have to provide the whole thing. So here I'm gonna use the list thing. So I'm gonna update things in place and then put the list back in the thing. So here I'm gonna collect the list. Collect list is equal await this read, and then what's the item? The item will be list, and we're gonna find the item. The same way we did that. So every matcher match keys. Yeah, this is correct. And then we can say if it's item, but it's better if I find the index to do things like this. But maybe I can update this thing in place. No. So what would best be if I want to match the item? Okay, I got the item, but I don't know where that is. Maybe we can find index. Item index. And what we're gonna, if item index, I'm gonna do list item index. That's what we're gonna return. Otherwise, we're gonna return null. Say that we didn't update. So here we're gonna say item index is equal item index spread the data, and then we're gonna await this save the entire list. So we just pretty much updating the item in place and saving the list back again into the file. That could be one way to do it. So we can see the JSON here. Let's see how many John Doe's pending we have. We have John Doe's only one pending to go to the gym. It's gonna make John Doe go to the gym now. So we're gonna update one. We're gonna start to complete it, and we're gonna get this, and we're gonna run this baby. There you go. Now go to the gym is now completed. If you check the date JSON, we know that John Doe go to the gym is now completed. So you can see everything is fine. Let's do an update all. First, let's just go through this all again. Update all. So that's batch update. So how do we update all? So matchers, I'm still gonna get the list. And in this case, what we can do is go through the list. We're gonna update in space list for each item. We're gonna if it matches the item no, actually we'll just do a map, and we're gonna map. If it matches, we're gonna return item, or we're gonna return data, and we just save the list again. But in this case, I want to collect the changed item. So I want to return it. Oh, we also have to update this. So this run return collection of T. So let me see what I did for update one. Update one, it's gonna return up null. If it's not, no. So I was gonna return a T. CD is gonna get promise of T's if they exist, and this is gonna be T array. So for every time this just array works. So we're gonna update it items, push period item, and that's pretty much it. Yeah, we can do update all here. So how does delete one looks like? Delete one should be an interesting one. So let's just copy this one. Delete one. Delete one does not take anything. Yeah, we can just say delete one where la-di-da-di. So in this case, we're gonna do a filter. Yeah, we're gonna do a filter. I'm gonna say delete. To delete. So if should delete, deleted items, we're gonna call it deleted items. We're gonna say deleted items push item should delete. So if you should delete, it will not include in the list, and this will do. No, this actually update all. Yeah, the update one should be much simpler. We're just gonna use the same thing here. Same thing with update one. Let's use transform the update one into delete one. Jesus. Delete one. List, find the index. It's more than that. We're just gonna do delete list item index. Save the list, and that's it. Delete one. Yeah, should be. Oh, I call it delete. Delete one. Delete one. What delete ones does? It returns a T or a null. That's correct. Update one. Delete all returns T. Yeah. So we save it. So that's pretty much it. Just to cherry on top, I'm gonna do async drop the database. The most dangerous action. I'm gonna await, and I'm gonna here pull the unlink this file path. So as you can see, this database is fun to work with. You can get to play with a lot of things in JavaScript. If you want to get the code of this, I have a blog post where on Medium that you can go ahead and follow me. I normally share everything on blogs before I make YouTube videos. You can go there. You can actually access all the code that I have here. I actually have more details. But if you just want to use this in general, this is already packaged into a Node.json DB. NPM that you can just go add everything that here that you can explore, and everything that we just covered on this video that you can just use as right away to do your stuff. Let me know what you think in the comments. Like and subscribe to support the channel. Once again, thanks for watching. Catch you next one. Bye bye.